Okay, while everybody's waiting for mine here, so if you type x equals 2 plus 2 object, that was the word I was looking for, x becomes an object containing the results of that operation. Okay, so it may not seem like it's that useful to just say x is equal to 4, but we can make these into variables. We can make these into vectors. There's all types of things that we can do as we get more advanced here. Now, data structure is something I think people are often challenged by. And what we need to remember is things like vectors and matrices and arrays. Lists, I don't personally use that often. Some of you may find they're very important. That's based on your own user experience. What's a vector? That's a question that every single person who's taken my class should be able to answer. What is a vector in the case of R? Single dimension? Okay, so a single dimension being a single row in an Excel spreadsheet, for instance, or one column in an Excel spreadsheet. That would be a vector. So a one-dimensional line of numbers, separated by positions. Just like an Excel spreadsheet, you have cells. And in this case, maybe we're separating it by commas to enter it in. Let's see if RStudio is okay. Okay, now when we type X, we get 4. I think I'm going to suggest that instead of leaving packages open here, you click off of that tab once you've loaded QTL, because then it shouldn't, if you make any changes, it shouldn't try and update those. There's 35 gigs of packages there, so. So x equals 2 plus 2, or we can change this into a vector, and the C is a way that we concatenate all those numbers. So now when I type x, we get this string. How many positions are here? 5. 1, 2, 3, 4, 5. So that's a one-dimensional vector. Now, what is a matrix? Two-dimensional. Okay, so we'll make a matrix in the next set of slides here. So there's multiple different ways that we can enter in strings of numbers. So one example here is to concatenate these numbers. If you had a regular sequence of numbers, you can add this this colon. And if we type that in, and now type x, x has been assigned all the numbers of 1 through 10. I don't know how to make that code go to the top. Are there people having problems with it freezing like this once stuff's loaded? Yes, sir. I'm totally locked up. Okay. I'll just be patient. Okay, so we also have operators we can add, some that are built into R, some that will come in the packages that you load. So an example is log. Log has a definition of performing the log base 10 operation. I would highly discourage you from trying to assign new objects to things that are existing operators. For instance, you don't want to call, instead of calling it x, you don't want to call it log is equal to 4. Right? Because log is an actual function in an operator that's going to have an effect. It's going to take the log of 100. So we need to be cognizant of what type of code we're writing here and to use things that make sense. So x would be a variable in this case that we might change. Nope, I'm totally locked up. So everybody's in RStudio, but if you type ls and then 2 parentheses, it'll list out the various things that you have in the memory. So right now it should just be x, unless you were writing your own stuff while we were talking. But you'll also see in the RStudio version, in your environment, it'll tell you what you've assigned these values to. And I think that's one of the things that people really like about RStudio rather than just R. Oh, come on. Question is if it's worth shutting RStudio down and reopening it at this point when it locks up. You think so? No, we're not maxing out the CPU or the physical memory, so. Let's see if that works. There we go. It just needed to be threatened with being shut down. Oh, that's cool. Okay. So if you did ls, you would be able to see in here that so far what we have in our memory is x. And there's a function that you can use, rm x, and that's going to delete it from your memory. So now when you type x, there's nothing in there. So the way I use R is I generally write scripts, and I write these scripts in a notepad file. Now, you might find with a package or with whatever Carl's going to show you tomorrow, there might be a better way to do this with RStudio. But I'll show you a brief example of a script I wrote here that we'll use for QTL mapping later, where I assign various objects data, and then we're going to manipulate this data, and then we're going to run an analysis on this data, and then we're going to plot this data. So this single script here, we can copy this whole thing and paste it into RStudio, and RStudio will choke. Okay, so it did all of these operations all at once. Runs the whole thing, calculates the output, makes the plot. And now we can look in our data and our values and see that all these things are assigned something. Yeah. Mm-hmm. Okay. And the nice part about RStudio and other things like TinR is it color codes these things for you, right? So you can see here's your object, and then here's the data within the object that you're assigning. Steven, you had a comment? Okay. Cool. Okay, but this is a script. I just wanted to show everyone here who may not be familiar what a script might be or the program that you're going to be running. Now, there's lots of different types of text editors that you can use for this. I'm guessing since we're going to be using RStudio for all 3 of the sessions, RStudio would be the most logical script text editor that you'll be using. Now, the thing that people like about RStudio and TinR is that it does add somewhat of a GUI. There's a little bit more of a point and click and a few other things you can do. I didn't open up R. I don't know if we had to have put R in the program. So the base R is very bare bones, and everything you do in this is command line. And that's why I use notepad files and copy and paste them over. Okay. So obviously RStudio adds some other things, like you can see these variables, you can get the plots in a separate window, all very nice things. Okay, so packages. So when you went into the packages and you had that huge list and we searched for QTL, you clicked that little checkbox and it loaded that automatically. Now for most of you on your personal computer, you would not download all of the packages at once. You would go to the Texas, one of the Texas sites and download just the package you need and then install just that package into R. You only need to do that once to install the package once, and then it is in R and in the R directory. But every time you open RStudio, you're going to need to load the package. Part of the reason we do that is because if you were to load all those packages, it would really bog down the software. There's a lot of extra stuff in there that you wouldn't need for day-to-day operations. Hey, welcome. So just to get you guys on the same page, let's see, I think there's only 2 computers open, is that right? Okay, and so for the people who just got here, it's going to take a long time, or a fairly long time, for this to load. So I'm going to walk you through it real quick. Go to the Start button here at the bottom, All Programs, and then go to Applications, and RStudio is in there. So you go ahead and click on that, and it's going to take a while for it to open. It's going to look like the computer froze up. So RQTL and MPMap are packages that will be operating within our environment. I don't think I can emphasize enough that the way I've learned R and the way I think everybody is going to learn a program like R is by having a problem and troubleshooting it. Okay? And so how do you troubleshoot it? Where do you go for help? And I find that this is a skill set that can't really be taught. There's some people who are much better at sort of figuring out how to figure things out than others. So I'm going to give you the best tips and tricks I can give you. So first of all, get the baseline introduction to R. So if you haven't already had that, please spend the time tonight and go through some of the tutorials in an introduction to R. The other thing is to be able to look for help. So I use Google or a search engine quite often. I'll type in my query and I'll look for help forums where people have discussed the same issue. And 95% of the time, I can solve it within about 5 minutes. With R, there's all these different types of functions. Whether you want to do, pull out some vector from a matrix, or there's just different types of coding that Sandra can do and I can do, and we both come up with completely different ways to go ahead and get to the root of that. Okay? So there's no right way to do things a lot of time. There's a lot of different ways, and I know my sets of tricks, and Steven knows his sets of tricks, and now I know that I can do Control R and it'll paste code in RStudio. If you can't find it using a regular search for R, I add CRAN. I've already told you that, C-R-A-N. That tends to pull things out. And I think where people really struggle is thinking about alternative search terms. If you have to dig that deep for this, I don't think you're using the right search term, because something should pop up to answer your question fairly quickly. The last thing that's really a nice native function of R is being able to type this question mark to understand how a function operates. So if I told everybody, let's see, what did we simulate there for some of our QTL analysis? All right, I'm going to ask everybody to type this in here. Capital AA is less than dash, so that's our equal sign. That's assigning that object some function or numbers. R norm, R-N-O-R-M, parentheses 50, comma 102, comma 6, close the parentheses. So I'm going to do that right now. Okay, and it looks like nothing happened. It just went down. Can people see down here in the back? I wish I could bring that up somehow. Let me try this. I tried dragging the console up and it didn't do anything. I'd rather just swap it with this up here, and I don't know a way I can do that. Huh? This? But that's only going to bring the console up here. It's still going to be everything I typed down here is going to be at the bottom of the screen. I was hoping I could swap the source and the console. So did you say session? You said settings. I don't see a settings. Probably under tools. There we go. Thank you. Okay. Yeah, because we're probably not going to use this down here too much. The console is going to be our main window. Okay, so everybody typed AA rnorm. Okay, so now if you type capital AA again, and hopefully when I told you to type AA, you saw it was capital. Okay, and so here's all of these numbers. What are these numbers? Random numbers. And so how were those random numbers generated? With the rnorm function, but so what were our parameters for that? How do you know that? Okay, but for everybody who hasn't done this before, how would they find that out? Question mark rnorm. So you type this up. Again, RStudio does it a little differently. It pops it up here. But it's going to give you a description of what that function did. So here's our description: density distribution function, quantile function, and random generation in that order. So rnorm is the random number generator. And it has these parameters: n, mean, standard deviation. And this just means the mean default is 0 and the standard deviation is 1. If you typed in what I told you to, the mean you gave it was 102, the standard deviation was 6, and the n, we can go down here and find out it's our number of observations. So what you did was you generated 50 random numbers with a mean of 102 and a standard deviation of 6. Is that approximately what you would expect? Yes or no? I hope so. Since you all watched me do it, I didn't cheat. Now, It's important to remember, though, if you got a different answer, I'm going to do the same thing again, okay, using the up arrows to go back to my old code. And now I get a completely different answer. See, this one started with 99, this one started with 79, and that's because we used a random number generating function. Now for our QTL and for MP map, you almost certainly aren't going to be generating random numbers. Okay, that's just what I usually do for the type of analysis and things we do in our class. But that gives you a good example that you can try. Mm-hmm. So, for instance, if I wanted to do random number generation, I think it's thinking. Or it's thinking about thinking. And I'm not getting a prompt here, so it's still thinking. But yes, the double question mark can help you look for search terms. I tend to just go to Google at that point and type in a search term. But if I know what I'm looking for and trying to remember how to set it up, like what order, which is the mean, or what's the parameter at which part, a question mark is pretty helpful for that. So I mentioned before that we can develop these objects as series of numbers. The other thing we can do is we can manipulate two objects together. So in this case, and everybody can do this, x is equal to the series of 1 to 25. And remember, we're not using equal to, we're using this less than and a dash sign. And y is equal to the series of numbers between 12 and negative 12. And then that hashtag or the pound symbol just tells me, or tells you, here's a note. We want to hit return. That's still thinking. There's a stop button on R. Looks like there's on R Studio as well, right there, and that'll cancel our operation. So I was using x is equal to 1 to 25 and y is equal to 12 to negative 12. So we type that in, okay, and now I can type x, and it'll return those variables. Y, it'll return those, and then what we can do is we can create a new object of multiplying them together. So x part 2 is equal to x times y. X part 2 is equal to x times y. And now I need to type it back in. And so that's the multiplication product of the vector of x times the vector of y. Okay. So that's just an example of how we might manipulate two objects with each other. And for some of you, this is definitely beyond refresher. This is like refresher of refresher. But for other of you, hopefully you're learning something here. I mentioned different functions before, so just give you a couple examples. ABS is an absolute number function. So if we type ABS, then whatever is in the parentheses, it will take the absolute value of. So these functions apply to the things that are then within the parentheses. Now when we go to matrices, we're going to see that parentheses are different than brackets. And if we went to a loop function, we'd see that parentheses are different than brackets, are different than curly brackets. So everybody typed in this x, x, y, x part 2 is this. So now we're going to type in x part 2 abs is the absolute value of x part 2. So we do this. Can I click on this and get the results in the window? That'd be too convenient. So just to show you what it did, X part 2 ABS is going to give you the absolute value of the same number series that you had X part 2. And now what we can do is we can plot these. Now to plot, a basic scatter plot in R is very easy. It's just the function plot with a parenthesis, your X values and your Y values. But it's very, very important that your vectors for your X values and your Y vectors values are exactly the same length. If they differ in length, it'll give you an error. And there's our plot of X with as the absolute value versus X with the negative numbers still in it. Good? We can check that off the list? That was a pun. It's a check figure. Never mind. So how would we bring up, if we didn't know what to do in a plot, how would we bring that up? How would we find out what to enter in there? Right? A question mark. So question mark plot will bring up the help function for plot. And again, for me, this has been the most effective way for me to learn things in R, is to use this question mark. Generic XY plotting, and it gives you a lot of links you can go to get other help. Okay, so here are our arguments. It explains what X and Y are, and then various code to manipulate that plot. Okay, the next step is a matrix, and I think this is where we actually get into what's going to be useful. So if a vector is one-dimensional and a matrix is two-dimensional, we can pull out vectors from that matrix. So I'd like everybody to type this in, matrix 1, and this is actually bad code. You shouldn't write it all in caps here. It should be capital matrix. But matrix 1 is equal to matrix, parentheses, 7, 5, and 10. So matrix 1. And why do I say matrix 1 rather than matrix? Well, matrix is an actual function. And so if I was to type matrix is equal to matrix, I don't know if RStudio would let you overwrite that function, but bad things could happen. The internet could explode if you do this incorrectly. So. Okay, so there's my matrix. And now if I type that out, I should see a matrix of 7s. So now we could take slices of this matrix, or individual vectors, and it gives you a little hint right here how to do this. So this is matrix 1, and this is position number 4, that vector, and here's position number comma 4 in that vector. So let me just show you that real briefly. So if I do matrix, and then these are the square brackets, 4 comma matrix 1, 4 comma, it's giving me this slice of 7s. And if I do comma 4, it's going to give me the slice of 7s. Now because they're vectors, it's going to lay them out sideways here. But in space, we need to remember that they're positioned as column and not as a row. Since they're all 7s, it's kind of hard for you to be able to see which slice it's taking out. You could, of course, put your own data in there. We could do matrix 2 is a matrix of 1 to 12, 5, 10. And now what we're saying in this case is we're going to assign the numbers of 1 through 12 through each of these positions, And I think it goes from left to right from top to bottom. So this will be 1 to 10, and then 11 to 12, and then 1 to 10, and it'll recycle that a second time. Hopefully that's a warning message, but that didn't actually affect us. Yeah. Sorry, I guess it fills it from this direction, down that way. Okay. So now if you take a slice of matrix 2, you can ensure that I'm not lying to you, and that the fourth position here, spelling counts. Just like my parents told me when I was growing up. I ignored them. It's true. So there's that vector right there, that slice of the matrix. Okay. Now for QTL mapping, what we're going to imagine having is we're going to imagine having a bunch of matrices. We're going to have a matrix of phenotypes, right, where you have a list of genotypes, maybe genotypes nested within environments, depends on how you set it up. And then the individual traits. So you might have your 30 genotypes, height, flowering time, etc. We also are going to have a matrix of genotypes. And so generally, the individuals are going to be on this axis here, and then we'd have position. So chromosome 1, marker 1, chromosome 1, marker 2, etc. So we're going to be dealing a lot more with matrices than we are with vectors. So what's the step after? So we have a vector, and then we go up to a matrix as two-dimensional. What's beyond that? An array. And how many dimensions can R handle? I mean, if we go from one-dimensional vector to two-dimensional matrix to three-dimensional array, can we go to a four-dimensional array? Yeah? Is there a limit? I was actually hoping if somebody could tell me. I have no idea. Once I get up to about 6 different dimensions, my brain can't process that anymore. So I've never tried to go beyond, actually really beyond 4. I've never used. Because there's better ways to deal with it. For instance, if we have multiple environments of the same individuals and the same traits, we could do one of two things. We could either make a 3-dimensional array, so we could have our genotypes coming down this way and our traits coming across, and then one matrix for each environment being our 3rd dimension. So you can imagine that as slices in front of each other. Or we could just add an indicator column and say environment 1, environment 2, environment 3, and then your data starts the next column over. Okay, so there are 2 ways to deal with that, and you'll find that not every program decides to do it the same way. But most people won't venture into matrices much more than 4 dimensions or arrays. So we can make an array. So here I have this code: array 1 is equal to an array of 7s. There's the data. And then the way you tell it the number of dimensions is with this concatenate function after the comma. So it's array 1 is equal to array in all lowercase, parenthesis 7, comma C, parenthesis 2, comma 3, comma 4, and then close the 2 parentheses. And so now if we type in array 1, we should see, indeed, it is a 2 by 3-dimensional matrix, but then that's put into a 3rd dimension of 4 different slices. So you can imagine we have genotypes and traits in 4 different environments, for instance. But setting up your data like this, the nice part about it is it makes it really easy to call things routinely. So if you wanted to run the same analysis on each of your environments separately, you can just have it cycle over this 3rd dimension. But like everything in R, there's a different way to do it if